Okay, so today we're going to be talking about section 3.2, which is solving inequalities by addition and subtraction. And so our objective is basically to solve one-step inequalities. And this is going to come into play just like what we did with one-step equations, but there's just a couple things that we need to be careful of. And so a couple things that we have to look at is remember, what do these mean? So these are our four inequality symbols that we'll typically use. And so when graphing, are these circles open or closed? And so you'll find out that these two here, these are open, which basically means that they do not include the endpoint as part of the solution. And then the next two, these ones here, are closed, meaning that they do include the endpoint as the solution. So that's just something that we're going to have to keep in mind. So these are open and these are closed, as far as these two being open and these two being closed. And so just like what we did with equations, we're going to investigate things a little bit. So here we have two inequalities, which as of right now are both true. And so we have 5 greater than 3, and then we have -2 is less than 9. And so we would agree that both of those are 2. Now, similar in the idea that we could basically add things to the same side and everything like that, if I did this, if I added 5 to this side, and I added 5 to this side, I would have 10 is greater than 8. And so basically what I've done is I've added the same amount to both sides, and I still had a true statement. And so that's kind of exactly what we did with equations, but if we notice, no matter what I do, that this inequality stays true. And in the same token, I could do this. I could subtract 5 from both sides, and what I would end up with is I would end up with -7 is less than 4, which is still also a true statement. And so the idea here is that we can manipulate these inequalities in the same fashion that we used to manipulate equations, where we could add the same number to both sides or we could subtract the same number from both sides. And everything remains true. The only difference here is that we still have an inequality, where before everything was equal, but here everything is still true, and that's what we're looking for. We're always looking for things to stay true, not necessarily just being equal. And so what this is going to bring us to is our two properties of inequality this time, because we still have an inequality after we add or subtract, but the idea is that we can still add and subtract the same number to both sides of an inequality, and everything remains true. And that's what we're looking for, because the trueness of that idea is what keeps everything the same, because as long as it's still true, then everything is fine. But the problem with inequalities that we have to be careful of is if I use the example 3 is less than 5, I added 2 to this side, added 3 to this side, 5 is still less than 8, but the idea here is that even though this is a true statement, there's an imbalance here. So the idea is that I still have to keep everything balanced, so I can't just add whatever I want to both sides to make it true. It always has to be the same number each time. And so therefore I can't do this, but what I could do is 3 is less than 5, which I could add 2 and then add 2 and then add 3 and add 3. As long as I was doing the same thing to both sides, everything is going to stay true. And like I said, what we're going to do is we're going to now end up solving equations, not necessarily solving equations, but the same thing that we did to solve equations, we're going to solve inequalities. And so we're going to use our properties of inequality to do this, but the idea is that everything is going to stay the same. And so I have x plus 9 is less than 15. And so we could think of numbers that we could potentially put in for x that would make this true. But what we're going to do is we're just going to solve this just like we would normally do with an equation. So if I'm adding 9, I'm going to subtract 9 from both sides. And this is exactly what we did in chapter 2. And so since I subtracted 9, both of these cancel, and then I get x is less than 6. And so basically every number that's less than 6 is going to be appropriate for this inequality. And the idea is that if we just say, well, it's got to be at least 5, but that's not necessarily true, because we can use x is equal to 5.999, which is still less than 6. So we can't just start at what we think the number is going to be, but we have to think about everything that is less than. And so this is every number that's less than 6. And you might see this as all real numbers less than 6. And that's another way that we can write that. But the idea is that we're going to solve these just like we did with equations, even though they're now inequalities. And on the other side here, what we can do is we have d minus 3 is greater than or equal to 6, or negative 6. And so we can solve for the variable d by just adding 3, because subtracting 3 and adding 3 are inverse. Add 3 to this side. These cancel, and I get d is greater than or equal to negative 3. And then there's our solutions. And so the idea here is that this would be all real numbers. Greater than or equal to negative 3. So it's basically any number that we can think of that's greater than or equal to negative 3, and those are our solutions. But we have to make sure that whenever we solve inequalities, we always need to show the solutions. And the reason that we show the solutions, like we talked about before, is because there's infinitely many solutions. And we can do this using our number line. So first of all, we're going to solve and get our inequality. So we're going to have plus 4 here, plus 4 here. That's going to get our variable n by itself. So 11 is greater than or equal to n. Or what I can do is I can flip this and say that n is less than or equal to 11. Now remember, the alligator or Pac-Man eats the larger number, so it's going to always try to eat 11, which is still the same case over here, so that we know that we did everything the way that it was supposed to be done. And so now that I have my inequality of n is less than or equal to 11, so n is less than or equal to 11, I can graph that on the number line. Now remember I told you have your 3-step kind of number line. So we have our endpoint, which is right in the middle, and we can go one above and one below. And so n is less than or equal to 11, so it's a closed circle at 11, and I'm shading everything to the left because I want all the numbers that are less than 11. And that's basically what we're doing to solve inequalities and then graph them on a number line. And so here's a couple more examples here for you. And so we're going to subtract 1 from both sides. So s is greater than 9. And so I can go to 9. This is an open circle at 9 because it's just the greater than. And then it's everything greater, which is always to the right. And then here, I can add 3.5 to both sides to get my answer. And that gives me q is less than or equal to negative 4. And so I go to negative 4, and now this is a closed circle at negative 4. Then I can go everything to the left. And so that's really all we're doing for solving and then graphing inequalities. And so the last thing that we have is we have a story problem. So we're still going to use those trigger words that we have to help us write and solve the inequality. And so Josh can bench press 210 pounds. He wants to bench press at least 282 pounds to break the school record. And so what we want to do is we want to write an inequality that would represent this. And this is how we would do this. Now I know some of you are already thinking about the difference between these two, but we want to write the general inequality. So if we do this, if we say P for the number of pounds that he can currently bench press, or not P, but we're going to start with 210 is the amount that he can currently bench press. If we add that to P, which is the number of pounds that he needs to add, needs to be at least 282. So what that's going to show us is a greater than or equal to 282. And the reason I know that is because 282 is the record. If he ties the record, he still kind of ties it. But the idea is that 282 will break the record. So if he can do 282, it'll break the record, and then everything beyond that is still something that he can do. He doesn't have to stop at 282. And so the way that we would do this is the number of pounds that he has plus what he can already do. We can go ahead and solve that by subtracting 210. And this is the idea that some of you probably already thought that I'm just going to subtract 282 and 210. And that's exactly what we end up doing. But we get the inequality of P is greater than or equal to 72. And then what we can do is we can go ahead and just graph that. Put 72 in the middle, and I'm going to go 80 on this side, and let's say 60 on this side. And so it's a closed circle at 72, and then everything to the right. And so the idea here is that we're just at least getting comfortable with creating inequalities, and we're solving inequalities. And with addition and subtraction, it works exactly how it does with equations. We basically either add or subtract the value away from the variable to cancel it out so that we can solve it. And as long as we're doing the same thing on both sides, everything will be fine. We can create our inequality like we did here, p is greater than or equal to 72, and then graph it on a number line. And that's basically going to do it for section 2 of chapter 3.